The next part of the meeting's agenda is going to talk about a few of the concepts of physics which you have already studied, and these concepts are worth remembering or getting reminded yourself. So whenever you are going to work on the physics for this hackathon, there are a few terms which you'll be having to remember. I would love to have somebody tell me what stress is and what strain is. Okay, these are the very fundamental definitions which we are refreshing again. So whenever there is a force acting, you try to standardize what is the value of force. So you simply divide it by area. So if suppose the area is large, even if the force is more, the body will still be able to take it. Okay. So for example, you can take a pen or a paper or something and then try to, yes, I got the comb over here. So if you look at this comb, I will be able to apply a force, a lot of force, and still it will be stable. But beyond a particular point, it will start to bend. Okay. On the other hand, this perfume bottle, I'm going to apply force. The same kind of force is still not going to make much of a difference. Okay. There are a lot of things which go into that. So let's go back to the heart of the matter we are talking about. So again, you'll also have studied about strain. Okay, so you will, for the very simple purpose, I'm just calling it as the ratio between the change in length by the original length. So for example, suppose there is a element, this element is being subjected to a pull. So when I am pulling this, automatically anybody will tell that this is going to exhibit some properties. The property is this is going to become a little longer, but it will become little, ouch. Yeah, it will also become a little thinner. Okay, so 1 minute. Sometimes the help which it tries to do is more of a nuisance. Sometimes when I want it, it will not come. When I don't want it, it comes in abundant measure. Anyways, guys, those are some of the things about technology. And as I always tell, I'm not the best of person to draw. Yeah. Anyway, this is this is absolutely crazy. Okay. So this is what happens whenever you are having a beam. Okay, it becomes a little thin, but it also becomes longer. Same thing happens if suppose I'm going to apply a force that pushes against it, the object will become fatter, but also it will become shorter. It will become fatter and shorter than the original condition it was in. Okay, so this change in length which you see, okay, for example, this may be del L by 2. Um, and this extension is going to be del L by 2, del L by 2. So this entire thing becomes del L, and the length is the original length of the element which was being pushed or pulled. Okay, so when you are going to go, you are going to encounter one more term, which is Young's modulus E. So you have one more term. I don't know why the pen is becoming so sensitive all of a sudden, but yeah, Young's modulus is nothing but your stress by strain. Okay, so this ratio essentially tells how easily something is going to bend or it is going to remain as it is. Okay, that is, even if there's a force, whether there's going to be a change or not, you will be able to measure with the Young's modulus. The other important term is going to be stiffness or I. So what happens essentially is you'll find that the deeper an element is, the less likely it is going to bend. I'm having a comb. I can bend the comb easily on the flat side, but if I'm going to keep it on the deeper side, that means with the teeth of the comb vertical, and I'm trying to bend it, you'll find that it's really not possible to bend the comb at all. Okay, so you can't bend the comb at all for certain reasons. So when you're going to look at I is nothing but the moment of inertia. Okay, different sections have different values of the moment of inertia. So we don't need to really worry too much about the moment of inertia in terms of the formulas. That moment of inertia is a measure of resistance to bending. Okay, moment of inertia is a measure of resistance to essentially rotation, okay, not bending, to rotation. Bending happens because there is a rotation basically. Again, you do remember in, I don't know, maybe in your 9th or 10th physics, you'd have had a doll put on a circular disc, and you can rotate the disc. If you take the weights away from the center of rotation of the doll, you'll find that it is very difficult to, the rotation actually, in fact, is very difficult to stop. So these are what you call as, the some of the concepts of physics which you have already done, which you are going to apply here. So what is the moral of the story? If moment of inertia is high, bending does not happen. Okay. So we'll again use the example which Professor Shashanka Bhushan had given us earlier. So there is this bridge. Okay, it is supposed to be a straight line. I was hoping it will become a straight line. It has not. Okay. Now here you'll find that the monkeys are on the bridge. Okay. So what essentially happens, if I don't want this bridge to bend a lot, you will be having to have a higher moment of inertia. So in the hackathon, you will have a question like, what value of I should be used so that the bridge doesn't bend beyond a particular value. Okay. So if I am going to keep the, if I'm going to keep the bridge with a load like, monkeys, then the bridge takes a bent shape. What value of I should I take so that the bending is very less? Okay. So probably you can, you'll be able to have a series of I values, which you'll have in a list. You'll keep putting each value by using a loop in Python, and essentially be able to see at what value of I this material will not bend beyond a particular level. Okay. So another thing is I can change the material. Usually when I change the material, whenever I change the material, the value of E will change unless both the materials are the same value of E. So maybe I can also change the value of E to find whether it doesn't bend that much. Okay. So these are some of the applications which you can work on. Okay. Now I can change the load. I can say that, baby monkey is there. So the baby monkey is, let's say, 1 kilogram. Daddy monkey is there. So maybe I should have used the, this is daddy monkey, let's say. Daddy monkey may be 11 kgs. Baby monkey may be standing here, 1 kg. Okay. So this may be another baby monkey, 1.5 kgs. It's a really tiny baby. So I can call this as 0.75 kgs. So you'll find that loads are there. If the monkey, if the daddy monkey comes to the middle of the bridge is going to bend more. Okay. You will be able to visualize this definitely. This is what is another thing that causes it to bend. You don't want it to bend beyond a particular level. You don't mind it bending slightly, but if it bends more, you don't like it. So this is another thing which you can work on. In the same way, you can do a lot of other things. Okay. So instead of having only the bridge, you can have a structure like this. You'll see this a lot in the metro systems, or you can also say, go to your the foodies, near foodies, you got this building. So you can just probably say, why not we have a shape like this? Okay. So you can keep imagining a lot of different things. Try to get the different geometries. Essentially, to get a geometry, you need 2 points, 0, 0. Okay. So let's say that this is 0, 5. Okay. And this is, let's say, 5 meters away, and let us say that this is 6 meter tall, and this will become 10 meters. So let me say that this is 10, 0, and this will become 10, 5. So once you have these coordinates done, you'll be able to make it. So you can also do this programmatically. Okay. So these are some of the things which you will be doing in your hackathon. So I know that these are all very, very simple things. You just need to apply a little bit of your mind, and you will be able to work on this quite easily. So we will, of course, be making it progressively challenging, but you don't have to think that it is going to be so difficult that nothing is going to work. Okay, so let's get to the Q&A part.